Sketch constraints represent physical conditions that you can apply to sketch figures to fix their orientation, position, or size. In many cases, the software places sketch constraints automatically for you. You can also apply these constraints manually. I'll enter in sketch mode now by selecting the XY plane as my sketch plane and then activating the 2D sketch. Notice as I sketch the line in the horizontal orientation, a horizontal constraint is inferred by the software. This is noted by the symbol that you see here. If I change the orientation of a line to the vertical position, a vertical constraint is also inferred. If I go ahead and double-click to place the line, the vertical constraint is applied, and you can see the constraint symbol shown next to the line. As I sketch new figures, other constraints may also be inferred. If I begin to sketch a line parallel to the first one, a parallel constraint is also inferred. If I make the lengths approximately the same, an equal constraint will be inferred. If I change the orientation, you will note that a perpendicular constraint can also be implied. If I move to finish a line on an existing endpoint, a coincident constraint is implied. Another example would be a tangential constraint. If I sketch a circle here, you can see a tangential constraint is inferred. These are just a few examples illustrating how the software can place constraints for you. I want to point out that you can override the placement of these inferred constraints as you sketch your figures. Once you've begun sketching the figure, if you hold down both the Control and Shift key while sketching, the constraints will no longer be inferred when you design your part. If I release the keys on the keyboard, the inferred constraints can return when creating a new sketch figure. Before we go on to applying constraints manually, I want to show you an option available to change the size of the constraint symbols in the work area. You can choose to display these symbols in larger font or regular font. To change the display, go to the Tools menu and select Options. On the General tab, you will see the option Large Constraint Symbols. If you check this option on, the symbols will be displayed in a larger font in your work area. Click OK if you made any changes to the options. I'm now going to introduce you to all of the constraints and show you how to apply them manually. You will want to become familiar with all of these constraints. The constraints are all accessible from the sketching toolbar. The constraint tools are not active until there is at least one sketch figure placed in the work area. You will see the constraint flyout if you click on the Options arrow. The available constraints are fixed, vertical, horizontal, intersection, symmetric, coradial, concentric, collinear, coincident, midline, equal, tangent, perpendicular, and parallel. You can also access the constraints by going to the Sketch menu and selecting Constraints. Now I'll go through each constraint and show you how to apply them. I'll just sketch a few figures here, including a sketch line and a couple of sketch nodes in random orientations. I'll also add in a reference line and a circle. If you want to lock a figure in place, you can use the Fixed constraint. From the Constraints flyout menu, simply select the Fix tool and this becomes active. To apply the constraint, move your mouse over the figures you want to lock and left-click. You will then see the fixed symbol appear next to the figure. This constraint is still active, so I will also left-click the sketch node and fix it in place. Once you've applied the fixed constraint to a figure, that figure can no longer be moved or resized. Notice as I try to move the line, it is locked into place. However, I can freely move the angled line that I have not yet constrained. Now I want to move on to the vertical constraint. I'll select the vertical constraint tool from the flyout, and to apply the constraint, I simply need to left-click on the figure I want to remain vertical. If I left-click this angled line, you can see it snaps to the vertical position. You can also apply vertical constraint to a sketch node. The constraint is still active, so I'll left-click on the sketch node and then the endpoints of this line. And then the second point selected will move so it is vertical to the first item. Moving on to the horizontal constraint, I can select the horizontal tool and then left-click on the line and snap it into place. You can see as I try to make modifications to the line, it remains in the horizontal position. Points can be horizontally aligned with each other, just as they can be vertically. I'll go ahead and apply a horizontal constraint between these two sketch nodes. Next is the intersection constraint. This constraint, just as all the ones we've already discussed, can also be inferred automatically. The first thing I will do is sketch two reference lines that intersect each other. Then I'll select the circle tool and move the mouse over the intersection point to the reference line. The intersection symbol appears at the location, so you can see that the software is inferring the intersection. The center of the circle will be automatically constrained to the intersection of these two lines. You can also place this manually. I've placed the circle away from the intersection of the lines, and now I will select the intersection constraint tool and then apply the constraint. To apply the constraint, I need to select the first line of the intersection, then the second figure of the intersection, and then finally the point that I want to move to the intersection. This time I'll sketch a vertical line that does not quite intersect with any other figures. However, there's a theoretical intersection point between it and the horizontal line. Then I'll sketch a circle away from the lines, and from the constraint flyout, select the intersection constraint again. I need to then select the first intersecting figure, then the second intersecting figure, and finally the point that I want to move to the intersection. As you can see, the center of the circle snaps to the theoretical intersection of these two lines. Notice that if I change the location of one of the lines, thus moving the theoretical intersection, the center of the circle will also move with it. For the final example, I'll sketch more reference lines, this time at an angled orientation. Next, I'll sketch a rectangle, and then I'll select the intersection constraint, select the first intersecting figure, then the second intersecting figure, and then finally the point I want to apply the constraint to. For that, I'll click the corner of the rectangle, and it will snap to the theoretical intersection point of the two lines. Now you will see that if I change the location of one of the lines, thus moving the theoretical intersection, the corner node of the rectangle will move as well. This concludes this segment of the video.